Afternoon, guys. So what I'm going to be doing this afternoon here, I'm going to be going through the solutions to the June 2022 CSEC Chem paper, right? All right, so the first question in the paper, an experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid, right? The procedure was as follows. So when you are given a question like this, what you need to do is to try to understand what is being asked in the question. So what they have done here, they said, okay, we add in magnesium plus hydrochloric acid, right? So before we do anything else, let's try to understand what's supposed to happen. So this is a metal reacting with an acid. So I'm going to get a salt, which in this case is going to be magnesium chloride plus hydrogen gas, right? So that's my products, magnesium chloride and hydrogen gas. As it stands, the equation is not balanced. So let me stick in a 2 here. Now, here's what I said. The procedure. 100 cm cube of 0.5 mole per dm cube hydrochloric acid is placed in a calorimeter. So basically, we have a styrofoam cup, right? So let's try to understand what's happening in the question. So you have a styrofoam cup. It has 100 cm cube, right? And this is your HCl. Yeah, this is your HCl, right? And the concentration of this HCl is 0.5 mole per dm cube. So this is 0.5 mole per dm cube, right? What are we going to do now? Sandpaper was used to clean a strip of magnesium ribbon until shiny, and 0.48 grams was weighed using a balance. So basically, we are putting a piece of magnesium inside of this here, right? So we put in magnesium solid inside of this thing here. The temperature of the hydrochloric acid in the calorimeter was measured every minute for 5 minutes. So inside this here, so inside this styrofoam cup, you have a thermometer. Right? So what else are we doing here, right? So you're recording the temperature every minute for 5 minutes. The magnesium strip was then added. Okay, so in step 4, you're adding the magnesium strip, right? But you're recording the temperature of the hydrochloric acid for 5 minutes, right? Magnesium strip was then added to the calorimeter with the hydrochloric acid. While stirring gently with the thermometer, the temperature is recorded every 15 seconds for 2 minutes. Okay, so I don't understand what's happening here. So initially we had the hydrochloric acid alone inside our styrofoam cup, and you're recording the temperature every minute for 5 minutes, right? And then now we added the magnesium strip, and then you're recording the temperature every 15 seconds for 2 minutes. Figure 1 shows the first 5 temperature readings during the experiment, right? Right, so this is figure 1 here, right? And this is the first 5 temperature readings here. So 15 to all right. What do they want me to do here now? Right, complete table 1 by recording the temperature readings in figure 1. So we need to go to the thermometer here, and we're going to read off each of these things here. So this one is for 15 seconds, and we need to look at the temperature that we are seeing here, right? Now, if we look at the temperature here, this first one is looking like 33 degrees Celsius. So this is 33 degrees Celsius. Let's read up the 30. This one here is 39.5 degrees Celsius. So it's 39.5 degrees Celsius. This next one here is 43 degrees Celsius. This next one here is 44.5. And this last one here is 46 degrees Celsius, right? So we've read off the temperatures, and what we need to do now, we need to put them in a table. So for 15, it's 33. So this one here is 33. For the next one, that's 30 seconds, that's 39.5. The next one here is 43 degrees. Next one here is 44.5. And the last one here is 46. Right? So basically, you all got 5 marks just for just for reading off some temperature readings, right? That's it, right? Yeah, so that's it. 5 marks. 5 marks just for reading off some temperatures, right? Next thing now, they said using the grid provided on page 7, plot a graph of temperature against time using the data in the table. And they said draw a best curve through the points. So we're getting 5 marks to draw this, right? Okay, so I need to get the data closer. Right, so this is my data here that I want to plot, right? So they already labeled the axes for us. We have temperature against time, so no biggie, right? So at 0, right, so we're reading off the first one here. At 0, that corresponds to 25 degrees. So I'm going to put a pointer here. Next one is 15 against 33. All right, let me make sure I understand the scale first now. So every two small marker represents 1, right? Every 2 represents 1. So I want to get 33. So 15 against 33, right? So this is 15, this is 31, 32. This here is 33, right? So that's my second point I'm plotting there. The next one is 30 against 39.5. So this here is 39, so here is 39.5. Next one here is 45 against 43. So 45 against 41, 42, 43 is up here. Next one is 60 against 44.5. So 40, this is 44, this is 44.5. Next one is 75 against 46. So 75 against 46 is right about here. Next one is 90 against 45.5. That's about here. Next one is 105 against 45.5 again, right? 105 against, so that's right here. And the last one is 120 against 45. 120 against 45. So that's here, right? So what they want me to draw now, they want me to draw what is, they said draw a curve, right? Normally when we do a thermometric titration, right? Now this is not a thermometric titration, right? What this is, we are reacting a metal with an acid. That's all we're doing, right? Reacting with a metal with an acid, right? So let's see. So I'm going to draw a smooth curve through this thing, right? So you start here. Now this is going to be kind of hard for me to draw, right? So bear with me. Right? It's not, we're not using a ruler for this because it's at a curve, right? Right? So we can work with that. That looks like it for me, right? So you're getting 5 marks just for plotting the points and sketching the curve. That's it, right? So that is part 2. The next part, using a graph, determine the temperature change delta T for the reaction. So delta T for the reaction is the difference between your highest temperature reach and your lowest temperature reach. If we look at the graph here, our lowest temperature is 25 and the highest temperature that we plotted, right, was actually 46, right? According to my graph there, it's 46. So what you guys should have done was take 46, our highest temperature, minus the 25, and that's going to give you 6 take away 5 is 1, 4 take away, so you're going to get 21 degrees Celsius, right? That's your change in temperature, right? All right, so next thing, they said state one difference between an endothermic and exothermic reaction, right? Now you could have selected whatever you wanted. So let me start with an endothermic reaction. So endothermic, right? You could have simply said, right? energy is released to the surroundings. Sorry, energy is absorbed from the surroundings, right? Energy is absorbed from the surroundings. Now they just wanted one difference, right? So you could have put whatever you want, right? So energy is absorbed from the surroundings, right? In the case of an exothermic, right, energy is released to the surroundings. Right? So that is one difference that we could say. There are two other possibilities. In the case of an endothermic reaction, there's a decrease in temperature. So if you had a reaction taking place in a test tube and you were to like hold the test tube, what's going to happen is that your hand is going to feel cold, or the test tube is going to feel cool because it's absorbing energy from your hand, right? And what happens, there's a temperature drop. There's a temperature drop for an endothermic reaction. In an exothermic reaction, energy is released, there's an increase in temperature, right? Another comparison that you can make has to do with the energy content of the products, right, and the reactants. In an endothermic reaction, the energy content of the products is greater than the energy content of the reactant. That's another possibility we can see. And for an exothermic reaction, the energy content of the product is less than the reactant, right? Yeah, you all asking about the delta T. The change in temperature is the difference. That's what it is. It's the difference. It's not just the final temperature. That's not what it is, right? Delta means change. That's what this is, all right? So it's 46 minus your initial temperature, right? So other ways we can compare these things is that, so we can look at, for endothermic, we can look at temperature change as well as heat content of your product and your reactant. Same thing for this one here. They want one, I'm just giving one. Next part, write a balanced chemical equation including state symbols for the reaction between magnesium metal and hydrochloric acid. So the broad topic said acids, bases, and salts. So this is what they were referring to, right? So this is HCl aqueous, right? Produces a salt, which in this case is going to be MgCl2 aqueous, right? Plus H2 gas. Right? And to balance this, all I need to do is to put a 2 here. Now you see how CXC asks, write a balanced chemical equation, right? And they said including state symbols. So if you don't balance it, you're going to lose a mark. If you don't put the state symbols, you're going to lose a mark as well, right? If you just write an equation, you're going to get 1 mark, right? That's why when you see balance and including state symbols, you have to include that. Now, part 2, they said calculate the number of moles of magnesium used in a reaction. So let's go back to the original question. They said we had, right, so this is how much magnesium they gave us, 0.48 grams, right? Where am I? Oh, sorry, I missed out a piece of the question. Hold on. State whether the reaction between magnesium and hydrochloric acid is endothermic or exothermic. Well, the fact that we have an increase in temperature means that this reaction has to be exothermic, right? So I missed that piece there, right? So, hold on, I forget the number already. 0.48 grams. All right, so they told us the relative atomic mass of magnesium. So all we need to do here is to say 24 grams, right, contains 1 mole, right? So therefore 0.48, right, contains, so in my online classes I never tell students to learn off any formula, so I'm going to cross multiply. So it's going to be 0.48 multiplied by 24 over 1, and that's going to give me how many moles I have in this thing here. So it's 0.48 multiplied by 24. Wait, that doesn't look right. Hold on. Yeah, that's because I'm writing craziness, right? It's 0.48 by 1. Hold on. over 24, right? 0.48 divided by 24. Yeah, so I'm getting 0.02 moles. Right? Yeah. So yeah, I made I just wrote the wrong thing there, right? So I'm now doing the paper. I didn't do the paper before. So if you see me making a mistake, let me know. All right. This I determine the volume of gas that would be collected if the reaction took place at STP. So that's standard temperature at pressure, right? Standard temperature and pressure, and they're telling me it's 22,400 cm3. Now your reaction, right? The chemical reaction that we had there was Mg solid plus 2HCl aqueous, right, produces MgCl2 aqueous, right, plus H2 gas. Now, the reason why they wanted us to balance this equation is that we need it here, right? According to this equation, 1 mole of magnesium solid produces 1 mole of gas, right? So according to that equation, 1 mole, right, Mg produces 1 mole H2 gas, right? Therefore, what we need to do, we already know how much moles of the magnesium we had, right? So I'm going to just write this over and say 1 mole Mg produces, right? Now 1 mole of a gas at STP is going to be 22400 cm3. Right? Therefore, we're going to use the answer we just got because that's the amount of moles of the magnesium we use, 0.02. So therefore 0.02 moles Mg produces, right? And I'm going to cross multiply again. So it's going to be 0.02 multiplied by 22400 all over 1. And when I work this out, that's the answer there. So 0.02 multiplied by 22400, and I'm going to get 448 cm3. And that's it there for 3 marks. Alright, so guys, I just needed to hit like and subscribe, right? I have a lot of information on my CSEC chemistry channel, right? So I was trying to figure out if to stream here or on the chemistry channel, right? So please hit like and hit subscribe as well, right? And those of you who may be thinking about chemistry classes, yes, I do give online chemistry classes, right? Right, now, this is the one that I got a lot of questions regarding, right? There was a little question regarding how you're calculating this. Calculate the energy change for the reaction between magnesium and hydrochloric acid. Now, to work out, they give you the formula. So the energy change, delta H, is given by M by C by delta T, right? Now, let's recap what happened here, right? You had a container, and that container had 100 cm3 of the hydrochloric acid, right? 100 cm3, and you added 0.48 grams of magnesium. Now, I got a lot of questions regarding what are we using for the mass, right? What are we using for the mass? Now, let's hold up on the mass for a sec, right? So you're multiplying by C. They told you what C is. C is 4.2, right? We're assuming that the specific heat capacity of the solution is 4.2. Multiplied it by your delta T. Well, we worked out delta T previously somewhere, Yeah, 21 degrees was our temperature change, right? So that's just 21, right? And students were trying to figure out, well, should we use 100 grams or should we use 100.48 grams? Now, this is one instance where it does not matter whether you use 100 or the 100.8, right? Sorry, 100.48. So watch something. I'm going to use 100 here, right? I'm going to work that out for you. 100 multiplied by 4.2 multiplied by 21, right? And I'm getting 8820 joules, right? Now, some students would have done this. Delta H is equal to M by C by delta T. And what they did, they would have added 100.48 multiplied by 4.2 multiplied by 21, right? So 100.48 multiplied by 4.2 by 21. And watch what you're going to get for your answer. 8862 joules. The difference in your answer is very small, right? Now, this is one instance where you don't necessarily have to add the 0.48, and I'll tell you why. Let me pull up. So you have 100 grams of liquid, right? 100 grams of liquid inside it. Now, the amount of magnesium that you're adding is only 0.48 grams, right? When you work out that 0.48 divided by 100, you're going to get a percentage, or you're going to get a ratio of 0.0048, right? Which means that 0.48 grams of the magnesium is negligible. So therefore, if students work it out with the 100 alone, you should get it correct. If you worked it with the 100.48, you should also get it correct, right? So for those of you who are worrying about that, do not worry about that. That 0.48 is very small in comparison to the volume of the acid that was used, right? Right, so 3 marks for that. The next thing they said, hence determine the energy change per mole of magnesium. Now, what we worked out here, so I'm going to be using this mass, this energy here, sorry. So that energy there is associated with how much moles of magnesium we had? 0.02. So all you guys had to do here was say 0.02 moles mg, right, gives us an energy change of 8820, right? Therefore, 1 mole magnesium is going to give me an energy change of 8820 over 0.02. So we're trying to work out the energy change per mole. So that is 8820 divided by 0.02. And you're going to get a big number. You're going to get 441,000 joules, or some of you may have written it like 441 kilojoules. Doesn't matter, right? Either way, it's only 1 mark for this. Right? So those of you scared about this piece here, this is the reason why it doesn't matter, right? I've seen two exams where CSEC asked the same question, right? And the mark scheme had 2 different things, right? So in this particular case, it does not matter, right? Whether you add it or you don't add it, because the mass of the magnesium is very small in comparison to the mass of the acid used, right? All right, let's look at question 2 now. Steels are alloys widely used in the industry in place of iron metal, right? Define the term alloy. Well, this is straightforward, right? An alloy is basically a mixture of 2 or more metals, right? 2 or more metals. That's it for 1 mark, right? Nothing fancy there. Name 2 types of steel. Now, this is where some students, they weren't sure what they were asking, right? Now, steel, right? Now, to begin with, steel is an alloy of iron, right? That's the first thing. Steel is an alloy of iron, right? Now, two types of steel here. What we can say is stainless steel. So if you go to a kitchen and you pick up a spoon or a knife, stainless steel, that's what it is, right? And the next one here, you could say, right? Because some students, they kind of recognize we could put stainless steel and they won't show what else, right? What we can also say here is carbon steel, right? Now, in the case of stainless steel, it's iron, it's a mixture of iron, right? And chromium, right? And the reason why they add chromium to the steel is that it makes it resistant to corrosion. That's what they're saying here. And in the case of carbon steel now, that is a mixture of iron and carbon, right? Now, depending on how the composition of the carbon and iron is, it affects how the steel is going to be, right? Because if you put too much carbon, right, or too little, you can end up with a steel that is too brittle, right? You just hit it a lash and it breaks, right? So I see some people said they use mild and low carbon steel, right? I'm sure they're probably gonna have a range of answers here, right? I'm sure they're gonna have a range of answers because some students gonna have different different things inside there, right? Right, wait, somebody's asking me an important question there, right? Somebody's saying if the energy change, so let me just go back to this here. Somebody's asking whether the energy change should be negative. And that's a very good point, right? This is an exothermic reaction. If it's an exothermic reaction, it means that my delta H for the reaction is negative 441, right? But I more feel, because it's only one mark, I feel CXC will give you the mark either way. Whether you left the sign there or you didn't leave the sign, because they're concerned about the answer, right? But that's a very good point that somebody made there. Yeah, it should be negative if it's an exothermic reaction. I agree, right? All right, let's see. Right, so back to this, right? So this is what I would have said here, right? The next thing, state two enhanced properties of steel. Well, I would go back to my examples and from there, I can say something about it, right? So the enhanced properties is that it is a little more resistant to corrosion, right? And that is when comparing it to pure iron, right? And the next one here is that it is strong, right? It is stronger. Steel is stronger, right? So that's why we use steel in the manufacture of cars, in the manufacture of buildings, right? That's what we're using steel for. Now, many metal nitrates undergo thermal decomposition. The relative ease of the thermal decomposition, right, form can help determine their place in the reactivity series. So yes, right, so with my class, I covered this with them, right? We looked at the reactivity series, we looked at the action of heat on nitrates, carbonates, and hydroxides. That's what we need to know for the syllabus. And they have different reactions depending on the position in the reactivity series. Now, let's see, we have V, W, X, Y, and Z, right? And they are telling us, so like I said, guys, I did not do the papers yet. I looked at it, but I didn't do it. So let me know if you see I'm seeing any craziness, right? So W and Z produce the metal nitride. Now that tells me something. That tells me that those two metals are the most reactive. So therefore, this one here should be W and Z for sure. And if we get any metal oxide, nitrogen dioxide, and oxygen, that means that this here will be V, X, and Y. That's what you all should have given them there, right? They just wanted us to classify which was the most reactive, which one was the least reactive. That's it. Right, it's 2 marks for that. Now, if one of the more reactive metals was identified as sodium, right? So I know that I did this with my class. So sodium nitrate, right? That's a solid, and I'm gonna heat that. Now they already guided you here with the answer, because they said you're gonna get a nitrite and oxygen gas. So what we're gonna get, what may have given you a little trouble, was the formula for the nitrite, which is NaNO2 solid, right, plus oxygen gas. So that's your reaction there that's taking place, So they want a balanced chemical equation. This is not balanced. If I put a 2 here and a 2 here, is that balanced? 2 sodium, 2 nitrogen, 2 nitrogen. 3 2s are 6 oxygen on the left, 2 2s are 4 and 2 6. Yeah, so this equation is correct here. That's it for 2 marks. The next part, further tests were carried out on metals V, X, and Y. Each metal was the oxides of the other metals in a displacement reaction. So this is about displacement reaction. So what you all needed to know was that metals higher up in the reactivity series, or more reactive metals, are able to displace ones lower down in the reactivity series. So let's see. So this first observation, V did not react with any of the metal oxides. Well, that tells me something already. V has to be at the bottom. V has to be the least reactive. That's what that means, right? So this one is the least reactive, right? Next thing, they said X reacted with the oxides of V, right, and metal Y, successfully displacing the metals. So that is telling me that X is the most reactive. It's higher up in the reactivity series. And the next one here, Y reacted with the oxide of V, successfully displacing it. So what that means is that Y falls here. So therefore, this here is your most reactive, right? And we already know that this one here is the least reactive. Use the information to deduce the order of reactivity. Now, I always tell my class, pay attention to questions like these. How do they want the order of reactivity? Notice what I said, most reactive to least reactive. So therefore, it's going to go X, then Y, and then V, right? So that's the answer for that part. All right, so we're still on question 2, by the way. Tests were carried out on solution A to determine the cations present. The observations are presented in the table. Complete the table by inserting the inferences. Okay, so what is our reagent? We are testing for cation, and we're using sodium hydroxide. So you add sodium hydroxide, you get a green precipitate. Once you see green precipitate, all you're going to tell them is Fe2 plus present. That's it. Right? You're getting 1 mark just for saying that. Fe2 plus present. They didn't ask me for an equation, so I'm not even bothering us yet. Now, the next thing here, they said the green precipitate darkened, right, when left to stand and turned orange at the top of the test tube, right? Now, the thing is, let's see. Now, my first guess here is that the Fe2 plus is being oxidized to Fe3 plus. Right? So what we're going to get here is Fe3 plus present. Right? That's my guess for this one here. Right? Now the thing is, one second. We don't normally test, or at least at the CSEC level, right? We've never really tested for Cr3 plus, right? Which is chromium, right? Chromium is also greenish, right? Chromium is also greenish. But I'm going to stick with these two answers here. I'm going to stick with Fe2 plus and Fe3 plus, right? As my ions present at that point in time, right? For the next one here, we're using sodium hydroxide again, right? You add a small amount and you heat it gently. Now they said a colorless gas evolved with a pungent odor, and the gas turned damp red with plus blue. So therefore, if it's a gas with a pungent odor, the gas that we're talking about here is NH3 gas or ammonia gas, right? So that's the answer for this one here. It's ammonia gas, right? And they told us that a colorless solution formed. Now when you add sodium hydroxide and you're getting ammonia gas being produced, that tells me that NH4 plus ions present, right? So that's the other one there. That's ammonium ion they're talking about it. Right, so that's question 2. Third question, easy question, right? So I prep my online classes to do organic chem. Now, what I normally do, I finish my syllabus in Form 4, and I do over the syllabus in Form 5, and when I do it over in Form 5, I do it with past papers, right? So my Form 5 class actually did organic chemistry 3 times, right? My Form 5 class did it 3 times, so they should get these 2 questions correct because I looked at the questions and they were extremely easy, right? So this third one here, compound A, compound B, state the homologous series to which A belongs. So what does A belong to, right? If you look here, you have an acid group, so you're going to say a carboxylic acid, right? The other word we can use is alkanoic acid. So any one of those, you will get your 1 mark, right? Next part, state the functional group in compound A, right? So the functional group, right, is this group, right? So that's my functional group there. You can write that, or you can write carboxyl, right? So that's how I typically write the functional group for an acid. RCOH, that's it. Some of you all, if you had drawn it as well, you would also get a mark, right? So if you just draw this, you'll also get a mark, right? 1 mark for that. Next part, state the name of compound A. So we already know A is an acid, so we need to see how many carbons we have in it. Now some students, they tend to miss out one of the carbons, but if you look carefully, you have 4 carbons. So if it's 4 carbons, the name of this compound has to be, the root name has to be bute. So this is butanoic acid. Right? That's the name of compound A. Part 4, state whether compound A will undergo a condensation reaction or addition polymerization with alcohols. Right? State whether compound A will undergo a condensation reaction. Right, so A is an acid. And the question, if you read it carefully, they said, state whether compound A will undergo a condensation reaction or an addition polymerization with alcohols, right? So this is a kind of funny question actually. So compound A is an acid. If I react it with an alcohol, that's esterification we're talking about there, and that's a condensation reaction, right? So it's condensation, it's not an addition reaction. Right? And the reason why it's a condensation reaction is water molecules are being eliminated. That's what's happening there, right? All right, next one. State the homologous series to which compound B belongs. If we look at B, right, the fact that it has a double bond tells me that it's an alkene. So that's it. All you're going to say is alkene, 1 mark. Next one, write the functional group present in compound B. All you all need to do is to do this. Let's draw a double bond for them. That's it, right? Write the functional group, C double bond. And they said state the name of compound B. Now this one here, we need to be careful. You have 1, 2, 3, 4 carbons, right? Now, when you are naming an alkene, you have to state the position of your double bond. I hope that you all remembered to do that. So this compound here has 4 carbons, just like the acid. So therefore the root name is bute, right? But you have to indicate the position of the double bond. Now, I'm going to tell you something, and some of you all are going to be disappointed, right? Some of you all would have just put butene as your answer. CXC is going to give you that wrong, right? What you're going to have to do, you need to state the position of the double bond. To do that, you have to number your carbon atoms. So let's start from one end. It doesn't matter which end you start from. 1, 2, 3, 4. So therefore, my double bond is actually bonded to my first carbon and second carbon. So the name of this compound here is going to be 1-butene, or it's going to be called but-1-ene. That's the name that they want, right? So the answer for this part here is 1-butene, right? Or but-1-ene. That's the name of that compound. Right, so those of you worrying about what you got and what, well, right, all I can say is you should have been in my class, that's all, right? Alright, so we still on the question. This part C now. Figure 4 shows compound C, which has structural isomers. So this compound here now, right, is an alkene, because there are no double bonds, but they want us to define structural isomers. So structural isomers have the same molecular formula, but different structural formula. Right, that's it. 2 marks just for saying that, right? That's the same thing they're asking for the past few years. What is structural isomerism, right? All right, now the next thing that we want now, so 2 marks for that. Easy stuff again. They want us to draw this compound, draw two structural isomers of compound C, right? So let me just pull across compound C here for you all. Right, so this is my compound here, and I want to draw 2 isomers here. And there are some students who they make the mistake of they think they're drawing an isomer, but they're not, right? So the name, this compound has, how many carbons you have in this? 1, 2, 3, 4, 5, right? Let me just go back here. Hold on. Right, so this was but, right? This compound they gave us here has 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, so the name of this compound is pentene, right? So this here is pentene. Has 5 carbon atoms, right? And what they want us to do is to draw 2 isomers, right? So the easiest thing I could draw here is to draw 1, 2, 3, 4. Drop a carbon here. So this is the easiest one I can draw, right? Do they want the name of it? I'm not sure if they want the name as yet, right? But hold on. Right? So this is my first possible isomer, right? That's my first possible isomer. And if you want to name that, right, that is 2-methyl butane, right? I don't know if they asked us to name it, right? But it's 2-methyl butane. That's 1 isomer, right? Now, the next one that we could potentially draw here is, we can go 1, 2, 3, 4, 5, right? This is the only other isomer. So if you drew anything that does not look like this, then chances are it's not correct, right? right? And the name of this one here will be 2,2-dimethyl propane, right? 2,2-dimethyl propane, right? I don't know if they ask us in the next part to name it, but that's the name of these here, right? But all they want us to do is to draw fully displayed structure, and it's 4 marks, so they're giving you 2 marks for each one. That's it. Alrighty. Right, and that I think brings us to, no, we have our next part still. Right, the names of right, so this could have given you some trouble. They want the names, right? So I didn't realize they asked you that there. So the names here, like I said, is 2-methyl-butane, right? And the next one that I drew here was 2,2-dimethyl propane. 2,2-dimethyl. Right, so I could understand if you all got this one wrong. This name is a little hard to kind of come up with, right? That can be a little hard to come up with. Right, so that's question 3. Question 4 now. Question 4 was electrolysis, right? Figure 5 shows a line diagram representing an electrolytic cell used in electrolysis of aqueous copper 2 sulfate. So I've done this so many times in my class. Told them, so before we even do anything, let's label up some stuff here so we understand what's happening. So this electrolyte here is copper 2 sulfate, right? And I always tell them, CXC loves to bring this. So this is a blue solution. That's a blue solution. You have a battery here. So therefore A, right, because it's connected to the positive terminal, it's called the anode. And B is connected to the negative terminal of the battery. So this is my cathode. So before I even do anything, I need to understand what is happening here before I even look at the question, right? And if you look carefully, they said, hey, we're going to use copper electrodes, right? Because when you're doing electrolysis, on copper 2 sulfate, if you use graphite, you get one particular reaction taking place. And if you use copper, something else is going to happen, right? Alright, so I'm watching some of the answers that you all saying for the names. The answers that I give you here, those are the correct answers, right? Those are the correct names for these compounds, right? So I know some of you all saying some other stuff there, but hold on, let's just make sure. Hope I didn't make a mistake. Meet, eat, yeah, 2-methyl-butane. Good. Alright, let me come back here now to the electrolysis and see what we need to do. State whether the electrodes used are active or inert and give a reason for your answer. So this particular reaction here, we have copper electrodes and you have a copper 2 sulfate solution, right? So what's going to happen here, those electrodes are considered active electrodes. So you're going to say the electrodes, right, are active. And all you all need to say here is because, right, they take part in the reaction. Right? That's what's happening here. They take part in the reaction, right? The next part, describe what occurs at the cathode and anode in an electrolytic cell. Alright, so let me read what it's saying here. Describe what occurs at the cathode and the anode in an electrolytic cell. Right? So at the cathode, I'm making an assumption here. I don't know what they want us to really say here. At the cathode, right, that's the negative electrode, right? So you're going to say positive ions, right, which are called cations, migrate, right, positive ions migrate to this electrode, right? Because this question kind of broad here, so I'm not sure where they're coming from for this. And at the anode, right, which is your positive electrode, you're going to say negative ions. Right, which are called anions, migrate right. I was hoping that the question was in relation to what we just spoke about, the copper and the but let's see, let's move on, right? That is what I would probably say here, because they said describe what occurs at the cathode and what occurs at the anode. You can also say other things as well. At the cathode, you have positive ions migrating there. What happens to them is that they gain electrons, and at the anode, they lose electrons, right? So I'm not sure exactly where they're coming from, but this is the most obvious answer that I would give if I had to answer this, right? All right, let's do the next part now. State which electrode in figure 5 on page 16 is the cathode. Well, I already identified that, right? I already said that A is the anode. So look at easy 2 marks here. So this is the anode, and this here is the cathode. 1 mark each, right? The next thing they said here now, identify the ions that will migrate towards the cathode and the anode. Now, whenever you have a solution, so you have copper sulfate, right? Now all the ions present here, right? And this is copper sulfate aqueous. So how you analyze an electrolysis, we look at the obvious ions first. So you know you're going to have Cu2 plus aqueous. You know you're going to have SO42 minus aqueous, right? But at the same time, because you have this thing in solution, you're going to have H plus from the water, right? And you're going to have OH minus from the water as well, right? So I have 4 different ions present here. So they said identify the ions that will migrate towards the anode and the cathode. Now remember, the cathode is your negative electrode. So the ones that are going to move across there will be these 2. So you're going to have Cu2 plus aqueous, right? And you're going to have H plus aqueous as well. Those 2 are going to migrate towards there. At the anode, that's your positive electrode, these ions are going to go there. So this will be SO42 minus, right, aqueous, and you will also have OH minus aqueous, right? So those are the ions that are going to migrate towards the anode and towards the cathode. Now, write half equations to show the substances produced at the anode and at the cathode. So this is one of those things that some students they may have had a little trouble with, because they were trying to remember what's supposed to happen in this electrolysis reaction, right? What did you all put for that? So there are 2 reactions that take place. So at the anode, let's start with the anode, right? What's going to happen is that the anode actually goes into solution. So they want to know what's happening at the cathode and at the anode. So let me do the anode first, right? So the anode, right, which is copper solid, right, is actually going to be converted into Cu2 plus ions plus 2 electrons. So I'm kind of surprised they only gave 2 marks here. Normally they will give us about 6 marks to do that, right? So at the anode, that's what's happening here. The mass of the anode is going to decrease, and at the cathode now, we have a different reaction taking place there. What's happening there is that the copper ions in solution, right? The copper ions in solution, they are going to accept 2 electrons and become copper solid, right? So it's going to be Cu2 plus 2 electrons. So this one here is going to be Cu2 plus aqueous plus 2 electrons, right, produces Cu solid, right? So that's my half equations for what's happening in this particular reaction. Somebody's asking if you have the wrong and the right answer, right? So it really depends on the markers and what they decide, right? All right, using your answer in B part 1, B part 2, explain why a redox reaction, right? Why a redox reaction took place during the electrolysis of copper 2 sulfate, right? Now, remember, a redox reaction is one in which you have both oxidation and reduction taking place at the same time, right? Now, let's see what's happening here. 2 to 0. Right. So we're using our answers here to show why this is a redox, right? So in the first reaction, so at the cathode, right, the oxidation number or the oxidation state of copper changes from, so we're talking about this first reaction here, So the copper is changing from +2 to 0, right? Because you're going to copper solid on the side here. So you're changing from oxidation state +2 to 0. So if you're at +2 and you're going to oxidation state 0, that means that's a decrease in oxidation number. So this here is called reduction, right? And at the anode now, right, the oxidation state of copper changes from, so if you look at the second reaction here, right, you're going from copper solid this time. So you're going from 0 to, on the right hand side, we change into Cu2 plus. So the oxidation number changes to +2. If you are going from 0 to +2, that's an increase in oxidation number, and that's called oxidation, right? So that's all I want here for that part of the question. That's it. Yes, so somebody, right, so somebody said if they answered it in terms of electron loss or gain, right? Yeah, that's true. You can do that, right? You can do that. So another option here, if we look at the cathode, you are gaining electrons, right? Yeah, that's actually pretty good, right? So you can also say at the cathode, so this one here, right? That's gain of electrons. Right? And if you're gaining electrons, that is reduction, right? So I'm sure you all learned an acronym called oil rig, right? So in the first reaction, if you said it's a gain of electrons and it's reduction, that's a possible answer, right? So that's the thing, right? Sometimes they may have a mark scheme and they may be looking at the mark scheme and they have to cater for all different ways that students can answer, right? So in this case here, somebody's saying, why not answer in terms of electrons? Yes, you can. Right? For the second reaction here at the anode, you realize you're losing electron. So this one here is loss of electrons. Right? And if you have a loss of electrons, that's called oxidation. So yeah, you can do it that way as well. Right? So the acronym here is oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. That's it. So just one change that is likely to be observed at the cathode, right? So remember, in this particular, let's go back to the diagram. I always draw the diagram. I try not to guess. So what's happening here is that in the electrolyte here, your Cu2 plus ions are going to migrate and they're going to deposit around this here. So one change is that you're going to see copper, or you can say the mass of the cathode increases, right? So the mass of cathode increases. So that's one possible answer. The other answer could be copper, or you could say the cathode is coated with copper. Right? So you can say that there. That's fine. Next part now. Explain how the electrolytic cell can be modified to plate copper on a small piece of steel. Right? So they've asked this question several times, right? So the only change you guys need to make to the diagram, so I go back to the diagram here. Right, so we have the anode on the left side. So this is electrolysis they're asking us about here, right? Sorry, electroplating, right? So you have your anode here, your positive electrode, negative electrode. And if you want to plate something, what you would do right? So this here is your cathode. So therefore, what you need to do, you need to make this here, because copper is being deposited here. So you need to make this here your steel. That's what you need to do. You need to make that your steel, right? Your solution remains the same, right? And well, you already have this as copper here, right? This is already copper. So the question says, explain how the electrolytic cell can be modified to plate copper on a small piece of steel, right? So replace the cathode with the small piece of steel. That's it. That's all we need to say there. Alright, so moving on to the next question. So for those of you who have not done so as yet, please hit like as well as subscribe. Not just like alone, subscribe as well, right? Alright, this next one, question 5. Organic chem again. State 4 general characteristics of a homologous series. So they asked this exact same question for the past few years, right? Even in the January 2022, I think they asked the same thing. So 1. Right, same general formula. There are 5 of them we need to know, but they only want 4. So same general formula. Right, 2, same functional group. Right, so these are easy 4 marks if you did review this. So same functional group, third one, similar chemical properties. Right, 4 adjacent members. Differ by CH2, right? And the 5th one, physical properties. Right, they only want 4, but I'm just giving you what the 5 are. Right, physical properties vary with the number of carbon atoms. Right, so they only want 4, that's it. Write the general formula of the alcohol homologous series and the molecular formula of the 5th one, right? So the alcohol, the general formula is CnH2n plus 1 OH. That's it. Easy 1 mark, right? That's standard thing here. Now, you want the formula for the 5th one. So therefore, you're substituting n equal to 5 into the formula. So it's going to be 2 by 5 plus 1 OH, right? And when I work this out, I'm going to get C5H11 OH. 5 2s are 10, yeah. So it's going to be C5H11 OH. That's it. Easy to marks. Alright, so I see somebody said can be prepared using the same general method. Yeah, that's one, but I don't ever use that as one of my reasons, right? These are the 5 that I use, right? Alright, so question, this one here. I don't know if you all realize this, but CXC did stupidness here because this compound cannot exist, right? So one thing that I pound in my students' head all the time is that you should never have more than 4 bonds around a carbon. So this is wrong. This diagram is wrong, right? Wrong. And I'll tell you why. Watch. Look at what CXC did here. Look at this carbon here. I have 5 bonds around this carbon. I have 5 bonds here. I have 5 bonds here, right? That is wrong, right? I messaged CXC to find out something once, and they tell me that they're doing some quality checks. So I don't know what quality checks they did with this paper, but this is wrong, right? So they said circle any 2 functional groups, right? So anyways, let me just, so to begin with, they're going to have to scrap this question. I'm telling you, they're going to have to scrap that because they can't have people answering wrong things, right? Now, so what they had to do, they need to remove this, right? They have to remove this. So they made a mistake when they were drawing this diagram. So what I'm going to do, I'm going to show you what the correct thing should be. So this is what the structure should be, and I'll tell you what the answer should be. 1, 2, 1, 2, 3. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we have a double bond. We have a carbon. 2, 3, 4. 1, 2, 3, 4. Alright, the structure getting kind of long though. Alright, so here, 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 here. Alright, then you have O, and you have C, C. So this is what the structure should have been, right? Alright, so this is my structure that CXC should have given me. And here's the answer that they probably wanted. So they said circle any 2 functional groups, and I can give you a few. So this one here is 1, right? And this is a carboxylic acid. This here is another one, that's an alkene. And here is another one, and that's an ester, right? So this here is an ester, right? This one here is an alkene. And this one here is a carboxylic acid, right? So like I said, I feel CXC just going to ignore this question because something is wrong with it. Right, next part C now. Experiments were carried out on 2 hydrocarbon gas samples, E and F, to determine which gas is ethane and which gas is ethene. Table 4 represents the experiment and observations, right? So we have two hydrocarbons here, E and F, right? And they said each hydrocarbon was bubbled through bromine water. So this one, the orange bromine water becomes colorless, and the next one you had no reaction. So automatically I can tell which one is which. But the first part, they said state the difference between alkyls and alkenes. So alkenes contain, so alkenes contain double bonds, right? You have plenty space here, so you could even put C, C, right? Alkenes contain double bonds, and alkanes contain single bonds, right? And when I say single bonds, I mean carbon to carbon single bonds, right? There's only one mark, so any simple answer you give, you'll get a mark. Using the observations in table 4, identify hydrocarbons E and F, right? So we just want to know which one is the alkane, which one is the alkene. So the alkene, the one that has the double bond, is going to have the color change with aqueous bromine. So therefore, orange bromine becomes colorless. So therefore, E has to be the alkene, right? And the other one, you had no change. So therefore, the other one has to be an alkene, right? That's it. State the conditions under which an alkane will react with bromine. So alkanes undergo substitution reactions. You want to react it with a halogen. So all you need to do is to use UV light. Right? That's it. That's all they want. Use UV light. All right, somebody said saturated, unsaturated. Yeah, that could work as well. Right, so somebody just said, for this one here, you can also say that for an alkane, it's saturated, yes. Right, and for an alkene, it's unsaturated. Yep, you can use that as well. All right, next part. Write a balanced chemical equation, including state symbols for the burning of ethene gas. Right? So 3 marks for this. So they want you to make sure you use the correct formula for ethene. Ethene is an alkene. It has 2 carbons in it. Right? So this is going to be C2H4. Right? Because it's an alkene. It's a gas. And you want to burn this thing in oxygen. So how I teach my class to balance this. The first thing we do, once you burn something in oxygen, hydrocarbon, you're going to get carbon dioxide gas. And you're going to get water. Those are my 2 products, right? Now, the next thing I teach them to do is to balance the carbon. On the left-hand side here, you have 2, so therefore I need to stick in a 2 here. You balance your hydrogen, you have 4 here, so therefore I need to put a 2 here if I want to get 4. The next thing to do is to balance your oxygen. On the right-hand side, you have a total of 2 2s of 4 and 2 6, so therefore we need to put a 3 here. And that's my answer for 3 marks. Alright guys, so like I said, hit like and subscribe, and I do give online lessons, right? My new Form 4 classes will be starting in August, right? So those are for students entering Form 4, right? And I will be taking Form 5 students as well, who will be writing next year. So that's, right, so this is the question that shocked a lot of people. I was not shocked at all, because I told my class, I said, hey, based on what they said on the broad topics, I want you all to have a look, just look back at green chemistry, because I have a strong feeling that it's going to come in your exam. So said, so done, right? CSEC would not have said green chemistry was coming because it would have been too obvious. If they said that, then you would have prepared adequately for that question, right? Because there's no other way. And I even knew what the first 2 questions was going to be. And that is, what is green chemistry? State 3 principles of green chemistry, and they're going to give you some application, right? So let's see what's happening here now. Right, so we have a chemical factory. It produces pesticides, right? It produces fertilizers, it produces plastics. So I said are bad things it produces, right? Using synthetic raw materials, right? The factory has been in operation for the past 5 years and is located near agricultural lands in a small rural community. So you have this factory somewhere in the bush, right? But it polluting the environment. Recently, the residents of the community have reported significant loss in plant and animal life due to increases in air pollutants, non-biodegradable solid waste, so that could be plastic they're talking about here, algal growth in nearby waterways. The increased toxicity has impacted the local agricultural economy. State 2 examples of air pollutants. What did you all put for that? 2 examples of air pollutants. What did you all put for that? Right, I've seen people saying carbon monoxide, methane, sulfur dioxide, carbon monoxide, right, hydrogen sulfide, sulfur. Yeah, so basically they would probably accept, and they would have a range of answers for this, right? So all you guys have to do is just give them a range of answers, right? So now if you notice, they said plastics, eh? So if you have plastics there, we could potentially have, so air pollutants, CFCs could be one, right? You can have SO2, yeah. They said they're producing pesticides and fertilizers, right? So you can have NO2, right? All of these things can be produced here, but I want 2 examples of air pollutants, right? Carbon dioxide, right, is a pollutant. It causes global warming, right? Carbon monoxide could also be given off. So basically, any valid answer will work there. So they would have a range of answers for this. So don't worry about that, right? Yeah, CFCs is one. That could be one. Because they have plastics. They're producing plastics here at the plant. So therefore CFCs, and also pesticides, right? Some of the pesticides have CFCs in them. All right, now, suggest 3 substances found in the products produced by the chemical factory that may have contributed to increased algal growth in waterways. What did you all say for that one? What causes algal bloom? Right? That's essentially what we're doing here. What causes algal bloom? Let's see what you all saying here. Right, so I've seen people saying nitrates, phosphates. Yeah, those are the things that contribute to the 3 substances, right? So one, we can say nitrates for sure, right? And that's for the fertilizers. So nitrates, right? Also phosphates, right? What else did you all put? Right, so they want 3 here, right? I know these 2 for sure, right? Nitrates and phosphates. Are we talking about increased algal growth? So we're talking about things that can be used as fertilizers, right? So detergents that contain phosphates, right? Nitrates. I don't know what else they wanted. right? So somebody's saying NPK. I guess substances that contain potassium in it, I suppose, right? Let's see. So we're missing one here, right? So we need some other thing there. I'm not sure what else they want us to put there, right? Now the next one here, some students did not bother to study green chemistry at all. So basically what green chemistry is, it is a proactive approach to pollution prevention. It involves designing chemical products and processes that reduces or eliminates the use of or the generation of hazardous substances. 1 mark for this. So any statement you make, right? Any statement that you make will work, right? Any valid statement you make will work. I don't think magnesium is one. I see you all saying magnesium. I don't think so. Magnesium is essential, yes, for chlorophyll, but I don't think that's the answer though. And when we're talking about fertilizers, we're talking about things like ammonium phosphate, ammonium nitrate, right? Those are fertilizers. All of those things contribute to algal bloom, right? Yeah, plants need magnesium for chlorophyll. Yeah, that's true. Right, I see you all saying carbon monoxide. Those things are not what cause eutrophication, right? If you all know what eutrophication is, basically you're adding all these nutrients to water. What happens is that it causes the excessive growth of algae, right? And that's what you call algal bloom, right? And somebody said they put 4 in case, right? I barely coming up with 3, right? So anyways, this is what green chemistry is, right? The next thing here, they said list 3 principles of green chemistry. So if you all read your notes, right? Or if you happen to learn this, because I normally tell my students, learn this 2 days before the exam, because it's not something that I spend too much time teaching, right? I give you there are 12 principles of green chemistry, right? So we have prevention. It is better to prevent waste formation rather than to treat it after the fact. Next one is atom economy. You're designing synthetic methods to maximize the incorporation of all the materials, so there's no waste. That's what we talk about, atom economy. The third one is less hazard, and what that means is that you're using a synthetic method, right, where you use or you're generating materials of low toxicity and impact to the environment, right? So it's less hazardous materials you're creating. Safer chemicals. Your chemical product design should preserve the efficacy while reducing toxicity. So after a while, some of them sound like they're very similar. So what I normally tell people, learn of 3 of them, right? Chances are they're going to apply it to something. Next one is use safe solvents, right? So we have 12 of them, right? We have 12 of them here. So all they wanted 3 of them, right? So I have 12 here, right? And that's something you can check up on your own, but that's on the syllabus, yes. And they want 3 principles of green chemistry. Any one you want, and that's it. Now this part here now is 6 marks. So I suspect a lot of people would have gotten problems with this, right? One, if you didn't study it at all, then you're gonna have issues, right? And worse yet, the question is asking me, explain how any of the 3 principles of green chemistry can be used by the factory to minimize the impact of pollution on the local agricultural economy. Now, if you go back to the question, your answer has to be related to what's here. So that you're producing pesticides, you're producing fertilizers, right? And you're producing plastics, right? Using synthetic raw materials, right? So that means that you're using, and they make sure and use the word synthetic here to kind of guide you. So if you read the question carefully, you realize the residents of the community reporting significant loss in plant, animal life due to air pollutants, non-biodegradable solid waste, algal growth in nearby waterways. So therefore, we kind of have an idea as to what happened in there. So what I've done, right? So every one that I haven't read is a potential answer for that, right? So in the first one, it is better to prevent waste formation than to treat it after it is formed. So in your process in the chemical plant, right, you're trying not to produce any waste material. That's what you're trying to do, right? Now, one of them I liked here was the last one here. The 11th one, which is real-time analysis for pollution prevention. So what you could do if you're a plant, right, and you're producing all these things, what you can do is have these HSE officers, and they go out to the nearby community. They measure the air sample to see if we have any hazardous gases there. We take samples from the rivers and streams to see what's going on, measure how much phosphate we have, how much nitrates we have, and then make some changes, right? The other thing that we can do, look, degradable design. So you design chemicals that are biodegradable. So when they enter the environment, they don't cause harm to the environment, right? They basically deteriorate over time. So that is what they were looking for in that last part there. So if I were to answer this, I'll use the real-time monitoring. That's a good example here, right? Because it's practical. You can see somebody measuring air samples to check how much sulfur dioxide we have in the air. You can see somebody taking samples from the river to test to see how much phosphates we have. The next thing is to design things that are biodegradable, right? If they are biodegradable, it means that when they enter the environment, they're going to decompose after a while, right? You don't want it to stay in the environment. So those two are good ones here, right? The next one here, you could choose any one of this here. Prevention, less hazard, or even safer chemicals. So whatever you're manufacturing here, try to use chemicals that are safer for the environment. That is how they want you to answer this particular question, guys, right? Right, so some people say they never did that. Yeah, well, that's under non-metals. That's the last thing that I teach, right? Alright, guys, so that brings us to the end of this this live here, right? So I have answered all the questions, right? So hopefully I didn't scare you all too much, right? And like I said, please hit like and subscribe, right? I've just worked the paper for you, right? You can thank me by hitting like and subscribe. And for those of you interested in maths, add maths, chemistry, and physics, I teach all of those things. So if you all have never seen these things and they all look new to you, well, you're in the wrong lessons class, guys. That's all I can say, right? If you want to come by the best, I'm here, right? Anyways, that's it for me, guys. Take care, right?